Determine each of the following. For part A, we have the integral of x squared plus 7x plus 14 all divided by x plus 3 is anti-differentiated with respect to x. So to simplify what's quite a complex quotient of two functions, or what's quite a complex expression, we're going to start using a method of division to try and simplify what we've been given. So we'll start out here by considering x plus 3, the denominator, equal to 0. And we're going to find that that would give x equals minus 3. So that is the number that we'll put here. And then along the top, we're going to put the coefficients of x squared, which is 1, the coefficient of x, which is 7, and the constant term of 14. So to do this synthetic division, we start by adding down the first column, and we simply get a 1 here. And then we're going to have 3 multiplied by 1 to give this term here. So that will be minus 3. And then we're going to add down the next column. So 7 plus negative 3 gives 4. And then we repeat the process of multiplying negative 3, and this time by 4, to give this number. So that gives us negative 12. And our last step is simply to add down the third column. So 14 plus negative 12 gives 2. So the 2 is the remainder after we've performed this division. So therefore our original integral can be written as 1x, so this 1 here becomes the coefficient of just x, so we're going to have x plus 4, so this term becomes the constant, and then we have the remainder 2 still divided by x plus 3, and that's going to be integrated with respect to x. So to anti-differentiate that, we simply take our x and we add 1 to the power, so we get x squared, and divide by the new power. Then we add on to that 4x, so anti-differentiating the constant 4 gives 4x. And then we have plus 2 times log e of x plus 3. And then we still have a plus c, which is the constant of integration. So that plus 2 over x plus 3 is a case where we can recognize that the derivative of the bottom is almost on the top. So we get 2 times log e of the denominator x plus 3. So that is the answer to part A of this example. For part B, we have 3x squared plus 6x, all divided by x plus 4. So we're going to do a similar thing as we did in part A. We're going to use a method of division. So I'm going to use synthetic division again to simplify what we're being asked to anti-differentiate. So starting with x plus 4, that is the denominator, equals 0. We find that x is equal to negative 4. So that is the term we're going to put here. And then we're going to put the coefficient of x squared here, so 3. And then we're going to have the coefficient of x here, which is 6. And then we're going to have the constant term, which is technically 0. So remember to put that in that third column. And now that we've got that set up, we start by adding down the first column. So that will give us 3. And then we take this negative 4 and we multiply it by 3 to give this value. So that will be negative 12. And then we add down our second column. And 6 plus negative 12 gives negative 6. And then we repeat the multiplication from before, which is minus 4. But this time we're going to multiply it by negative 6 to give this value. And that will give us positive 24 here. And then we simply add down the last column, which will give us 24. So 24 is the remainder after we've completed this division. So that means that our original integral can be written as 3x. So this 3 here becomes the coefficient of just x. And then the minus 6 is the new constant term. And then we have the remainder plus 24 divided by the x plus 4. So the original thing that we were dividing by. And we're going to anti-differentiate all of that with respect to x. So performing that anti-differentiation, we have 3x becomes 3x squared, and then we divide by the new power. Then we're going to have minus 6 becomes minus 6x, and then we're going to have plus 24 times log e of x plus 4, and then we still have plus c, which is our constant of integration. So that is the answer to part B of this example.